course. Okay, I'm the program leader, so I know you have been receiving all messages, this and that, from me on the WhatsApp group. That is actually me. And I'm going to be handling this course and also some other courses from year 2 and above. Okay, and I believe you have my contact details. If anything, you want to reach me through email or my number. Okay, so please do that. Okay. So other than that, you have this platform, WhatsApp group, Google Classroom, and in case if you need to see me face to face, we have already allocated our consultation hours, so you can book for the consultation in case if you need. Okay, because do let me know earlier because I'm not office person. I don't sit in the office. Okay, in case if you need to see me physically to discuss anything, do let me know earlier so that I can reserve myself here. Okay, got it? How many of you don't know my name? RSD. Have you seen my name on the timetable?
No.
Okay, that is my name. So RSD, I'm going to have a separate group with you guys later. Okay, I will create the WhatsApp group so that in case, like today, I was expecting I will be delayed and I might not able to update you guys because I update with the program lab of RSW. Okay, so later maybe any of you come and see me. Okay, so I have created this Google Classroom for our course. So I have already uploaded the course pack, the course plan, the lecture slides, the tutorial questions, and then practical hands-on materials, and also assignment. How many of you already seen Miss Yasota these two days? Already gone for tutorial, practical? Both. Okay, she already briefed the assignment? Okay, all okay, Okay, if anything, just do let me know. Okay. Okay. So I need to do some briefing about the course before we can start with the lecture slide. So you can find the course pack. Okay, about the course itself. Okay, for the coming batch, these one courses, we have separated them as two courses. I guess you are the last batch, I think. Okay, you are taking them together as one. Okay, start from new program structure. We already separated software testing and also software quality assurance. Okay, so here, this course is a combination of two different areas. One is software testing and one is software quality assurance. Okay, don't ask me how they get this name because they got the name before I'm here. Okay, software testing will be our major part which we are going to discuss. So out of total 12 chapters, the first 9 chapters we are going to discuss software testing. Okay, and the last 3 chapters we are going to discuss software quality assurance. Okay, software quality assurance going to be kind of boring, okay, because it's like too many theory things about the standards, about the quality, quality metrics, those kind of things. But the last 3 chapters, they are very important because I will not be assessing them in the midterm, and these 3 chapters will carry 50 marks in your final exam. Okay, most students, they fail the final exam because of these 50 marks. Because you know, right, when the bar is out, then they don't care about attendance anymore, they don't come for class anymore, and I could not help them. So these last 3 chapters is going to be towards the... Good morning, hello. Okay, so the last 3 chapters is going to be towards the last weeks of the semester, and you will see the numbers is going to be like 80% reduced during the lectures. Okay, so I cannot help it. So just to inform you, the last 3 chapters, no matter how terrible how horrible it's going to be, how boring it's going to be, it's okay. You come here and sleep. Got it? You wake up, you come here, you sleep here. At least something can go inside later, it can process. Okay? Okay, so this course is 3 credit hours as usual. So this course is going to be providing students to examine software quality by performing various testing activities, including producing some software testing documentation, which is going to be your assignment, okay, where you are going to be preparing the software test plan and also the test cases. Okay. Other than that, to use the testing techniques, managing tests, evaluating test results through theory and practical application that are involved in software testing lifecycle, not software development lifecycle. We have SDLC, right? What you have been learning for the past 2 semesters. Okay, from your software engineering 2163, you should know about this SDLC. Even RSD student, you guys take 2163 software engineering, right? So that is software development lifecycle. But here we are going to discuss software testing lifecycle. Okay, so software testing is actually one stage of the software development lifecycle, and software testing going to have its own lifecycle. Okay. So we have 3 different course learning outcomes which we need to achieve at least 75%. Okay, at least. If it's below 75%, it means you guys didn't perform well. I didn't perform well. Okay, so the first learning outcome, analyze the software testing concept, strategy or techniques for software testing cases. And then course learning outcome 2, adopt software quality standard in the development of software test plan and test cases. Then the third learning outcome, choose appropriate software quality assurance metrics, activities or standard in software testing. Okay, so the first learning outcomes is going to be assessed in your midterm. Okay, your midterm is going to be on week what? Have you seen on the course plan? Is it week 8? I think somewhere week 7 or week 8. Okay, so it's going to be more onto software testing, and the first normally I will put 6 to 7 chapters. Okay, because I don't assess the last chapters in your midterm. Okay, and the course learning outcome 1 also will be assessed in your final exam together with the course learning outcome 3. So this is 100% about the software quality assurance, which I said carry 50 marks. So CLO1, CLO3 is going to be assessed in your final exam. Okay, but CLO3 is not going to be assessed in your midterm. So that's why I said the last 3 chapters is not going to be assessed in your midterm. Okay, and your second learning outcome is going to be 100% assessing from your assignment. Okay, so at the end of the semester, after your result all out, we need to make sure that we have achieved 75% and above. Okay, hopefully SQAT no much issue, so hopefully we can maintain it because you guys have very big numbers this round. So hopefully RSD also okay. So all this is going to be the content of the course. So I will be referring to the course plan, how we have actually allocated them weekly basis for the 14 weeks. Okay, my reference here is 100% online reference, but actually in the library also there is hard copy books. Okay, but hard copy books is actually not updated. I mean, like it's kind of old already. So during MCO time, we started to use online reference, which is much more convenient for everyone. Okay, so if you want to refer reference book in library, please do that. Okay, software testing, software quality assurance books, they are there. Okay, so course plan, you can able to view it from your timetable. it big enough? Okay, so this is how we actually put weekly basis, how we are going to handle the lecture, the tutorial and practical. Okay, so as what I've mentioned, we have total of 12 chapters here. First 9 chapters is about the software testing, and the last 3 chapters going to be software quality assurance. Okay, so some of the chapters, they are kind of long chapters, so I might be dragging it for 2 different slot of lectures. So we will cover it for the 14 weeks. Okay, then tutorial, we are going to have 12 set of tutorial questions. So this is more 100% based on your chapter. So it means what you are discussing in the lecture for the chapter, that is what will be your tutorial question. So it's something like directly coming from the lecture knowledge. Okay. Then practical, our practical is going to be combination, actually it's 100% about the assignment. Okay, like software engineering 2163, you have done the, what is that, practical assignment, am I right? This one you already done with what is that, software requirement engineering, done. Formal method batch 1 year 1 done, year 2 formal method done. Formal method not yet. What are the software engineering courses you have done so far? Only 2. 2163 software engineering, and then 2033 software requirement engineering. Only these 2. Okay. Formal method this round, is it? Formal method this round, is it? What you are taking together with the SQAT? Software design. Okay. So formal method will be after this. Next time. Okay. So most of our software engineering courses, we try to bring this practical assignment, where on the weekly basis on your practical hours, we will be working together on your assignment. Okay, so like we are discussing about the assignment, you show the progress of your assignment, I will be commenting, and then we will have like a little presentation here and there for you to update your progress. So we don't have, especially this course, I don't have a formal presentation towards the end later, because your weekly presentation, weekly communication with me will be carried the mark. So we don't have a separate week for presentation alone. Okay, so what you are doing, that's what you are updating me on the weekly basis. Okay, so every week start from week 1. Okay, for those who I have made them for practical, okay, I already brief you guys on the assignment, what the assignment about, assignment task, and also we do the assignment grouping. So same thing goes when you are meeting your tutor, okay, they suppose should start with that. So for your week 1 practical, they must brief you the assignment, they must talk to you about the assignment, what is the task about, and then your grouping, and then also the system. Okay, so do let them know in case they don't know what to do. They suppose should know what to do. Okay, in case if they are practical, they don't know what is the meaning of what they are seeing here, do let them know. Okay, so every week we are going to be discussed on different areas of the assignment, and there are some hands-on things. Okay, for example, like when it's involved software testing technique, okay, software design technique. So this is actually involved with some hands-on, which you need to apply into your assignment. So we will be discussing some samples questions so that you can know how to do it in your assignment. So that's why I have some additional practical materials there. Okay, then other than that, I think that's it. So your midterm suppose should be on week 8, and then your assignment suppose should be submitting on week 12. Correct, right? Who have seen week 12 Friday? Correct, right? Okay. So let's see how the assignment progress is going to be, because sometimes some students, they might be requesting for extend, okay, especially when you are having like few submission continuously, okay. I know how is that. So in case if we need to do any extension of the deadline, sure we will do that. Okay. There's no aircon, is it? Or the aircon is too low for us? Why I cannot see any controller here?
Fan speed.
Is there any controller, temperature controller at the back? Is it like a fixed temperature here? Sorry, I never come to this East Campus. I have no idea. Nothing, is it? Can you see at the back? The one sitting at the back, is there any controller? Nothing. So we are going to die inside here every Wednesday. Wow. There is aircon, is it? There is, but it's like very mild one. Wow. Okay. So you can find all the lecture slide, the tutorial question, the practical and some things, and then assignment question. So here I'm doing the assignment grouping. So for the other groups with other tutor, you can ask the tutor to follow this, to put the grouping inside here, so that it will be easy for us to have one centralized place. Okay, so it's just a table things, and then for you to fill up the system you select, and then the team members. That's it, because it will be easy for you guys and also for the tutor. Okay, so let's start with our chapter 1. Okay, so as usual, chapter 1 is going to be always like introduction. Okay, always talk about what is this, what is that, okay, before we can go deeper. Okay, so our chapter 1 here going to be software testing concepts. So we want to recall back some things what you already discussed 2 semesters back. Wow, 2 semesters back. Do you think it's easy to recall back? Am I right? Not easy at all. Okay, let's try. Okay, so we are going to understand the basic concept of software testing. So we want to know what is this software testing, what is the purpose of software testing, what can happen if we do testing, what can happen if we don't do the testing. So these kind of things all we try to understand that. Then identify the importance of software testing, because if some companies out there, they out of resources or out of time and they want to skip the software testing, what will happen? So we want to know the importance. And then we are going to recall back principles of software testing. Okay. Okay, so when we are coming up with a software, because you have been discussing about software, develop software, coding, this and that. So when we are developing a software, can we guarantee our software is bug free? Can we say that my coding skill is too good? Okay, my logic sense is too good. So what I'm developing, I can guarantee that 100% going to work fine. There is no defect. So let's keep software testing and deploy the system straight to the working environment. Can it make sense? Can it make sense? We don't want to do the testing. Let's straightly deliver out to the client. Your client will be happy with that? Never. Because you cannot guarantee them without any proof, just because you say it out. Okay, just because you say that, okay, I can guarantee the software is bug free. But what is the proof? So the proof is actually what we get from our software testing. So it means what we test, what we get, the percentage of the pass test cases, the percentage of failed test cases, how many defects has been identified, how many defects has been fixed. All this information will be the proof to your client that you have done checking. Now I can guarantee the software can work. Okay, so in any situation, software testing cannot be skipped. Okay, so let's see some real situation, okay, or some cases. What happened? Are you guys done? 3 of you? Are you done talking? 3 of you. Are you done talking? Okay, can I continue? Or I need to give you additional time? Because your voice is really, really disturbing. Okay, so let's see some cases here. What happened or what kind of negative impact happened when we don't take software testing serious and there is defects happen. So all this is actually real cases. So doesn't matter how many years back the case happened, but it's still a case which we can see back. Okay, so this happened in 2005. So this there is a case happen using this hybrid car. How many of you using hybrid car here? How many of you fan of hybrid? Nobody. Why? I thought hybrid car is good. No one. Good. Okay. Then nobody using it. Why is good? It's even cheaper, right? Hybrid car, it's even cheaper than the normal version of car. And they will always give you like high percentage of rebate so that you can take it. What does that mean? They really want to sell it out. Correct? Okay, so of course it's a combination of 2 different techniques being used, right? Okay, but from what I have seen, of course I'm not using hybrid car. I mean from the real experience of someone who I know, when the battery gone, you know it's a battery, right? It's using the battery. The battery is actually much more expensive than the expenses of the car. So he ended up not changing the battery and using it as a normal fuel car. You get? Because to change the battery. And actually when I walk into this Nissan showroom, when I check about, because the person was really pushing the hybrid version of the Xtreme, you know. So I asked them, how is this battery work? How many times per week, or how I'm going to charge it? How long that 100% can be stayed? He cannot give me proper answer. Because the battery is actually not really good, I believe. I don't know what is the problem. So the way he was explaining to me, it didn't promise him at all. So I don't know, maybe you should know better what is the problem, or how good is it, or how bad is it. Okay, but here the problem is due to a software. Okay, so now all vehicles, they are coming with a software inside. Okay, so there is a issue happen. Okay, and they need to install a software to fix on 20 vehicles due to the problems with the invalid engine warning lights. So it means due to the invalid engine, there is a warning light happened. But actually, there is nothing wrong with the car. There is nothing wrong with the engine, but the system is having a problem. So due to this, they need to install an additional software on 20,000 vehicles. So what happened now? Due to this additional thing, because they didn't test the car system properly and they did not able to identify the whatever defect on the invalid engine things and the light parts. So they need to be spending 2 to 3 billion per year to fix these software problems. So what we lost here? Due to a simple defect. For sure it's a simple defect, am I right? The engine is good, but it's showing as a invalid engine, and due to that there is a warning light happening for no reason. You know, you are driving a car, the car is nicely going, but there is a warning light saying that your engine is invalid. Does it make sense? So to fix that, they need to install this software. Okay, so when they need to install the software, it's money. So additionally, you know what is additionally? Not what they have included into the project budget. So now they have spent 2 to 3 billion to fix that. So this is money lost. Got it? I don't know how they're able to sell the car, if they gain back that or not, but they spend a lot. Got it? Okay, so let's see another case. This one happened in 27, where there is a software fault happen in a popular online stock picking contest. So nowadays we have all this, right? So what happened here is, due to the defect, okay, so when they announce the winner, okay, where I think it's a cash, okay, so what happened is the 6th place, okay, the contestant on the 6th place has been the winner, because the software is only indicating that the top 5 contestant have been disqualified. Is it something fair? You know, you are at the 6th place. You have 5 more contestants on the top. You need to beat. Then only you can be a winner. Okay, and all of a sudden, due to a defect, you become the winner. And the first 5% is disqualified. Of course, it's fair enough for you because you got a large cash hat. But is it fair? Is it fair? It's not fair. Okay, so let's assume if it's something involved with something else other than large cash, maybe it might be causing different types of problems. Okay, so a simple defect make the first 5 contestants say status as disqualified, and then the 6th one become the winner. So let's assume there is problem in your CGPA calculation. Maybe this one is not really impacting you. So we know we have our we have our result system here, right? So what happened? According to the course you take, according to the grade, how many credit hours is going to calculate your CGPA. Got it? You have been working very hard. Okay, you have get A for everything. You suppose should get 4.0. Correct? And all of a sudden, due to defect, the miscalculation happened. Is it going to be fair for you? Are you going to be quiet? It's okay. I didn't get 4 point. It's not fair. So this kind of simple defects, which we actually able to identify earlier, has been ignored. And it can be giving different types of impact in the later stage. Okay. Then this one is in 2011. Okay, so this one is the Bitcoin system. Okay, where it's lost, there is a loss happen more than 850,000. Okay, Bitcoin, which is equivalent to $500 million due to the weakness in the system. So I'm not sure what kind of weakness happened. Maybe the trading or something. So they lost a big money. Okay. Then this is a point of sale which is happened in 2015, Starbucks. Okay, where the point of sale system of Starbucks encountered failure during the sales, daily sales. Okay, so what happened was it's not able to accept the payment or to make change. Can they continue to give free coffee? Cannot. So what happened? Okay, 60% of the system at the Starbucks, which is 13,500 location in the US and Canada, need to be shut down. Okay, so due to that, they lost around 3 million of sales. Okay, so this is also an example of loss of money. When it comes to your business, okay, when there is simple defect, and you can see how big impact it can be to your income. Okay, so other than loss of money, okay, because that might be a very low critical or low level of defects, okay, which is giving us impact in money matter. Okay, so let's assume if the system being used in hospitals, system being used for the system being used in how to say, like country defense system. You know what is country defense system? We are not going to have any Messiah, right? But let's assume, okay, we need to have all this system. Is that normal? Is he a part to go out from here? He's not in our class. He just entered and he just go out there. To feel the aircon for a while, is that? Okay, so let's assume if the system is being used in a very critical site, like in a medicine, in a healthcare, in operation theater, in ICU, or in country defensing system involving people's life. What will be the impact? Can we come up with robots now? Okay, we don't want to have soldiers anymore. They are not strong enough. So let's come up with the robots. You know, you watch a lot of movies, right? Where they are trying to replace the army team with the robots. What happened? The robots start to become violent. The robots start not to listen to human anymore. The movie which I like the most is iRobot. Have you watched iRobot? That was like years back. It should be like very old movie for you all. iRobot, Will Smith. How was the movie? Was good. Really, really was good. Because they are trying to put everything into the robot. Okay? Feelings. Right? But what happened? It's going to be totally blurred. Okay? So it starts to become against the human being. Okay? So this kind of system or defects in a system might be killing us. Okay, so the loss of money, something can be gained back. Okay, but let's assume if the defect impact is very high, it's going to kill us. So that's why it's very important when we develop a software, the software must pass through the testing first. For us to identify, I don't know how many defects we need to identify, but as much as possible, so that we can guarantee the software is ready to move to the working environment, so that the end user can use it without any issue. If we skip this, okay, the testing, it's going to give problem later. Okay, so this will be the type of negative impacts which can give us. Either it's going to be loss of big money, okay, or it's going to be loss of life. Okay. Are you in my class? Are you in the right class? No, at the back. I saw you walk out just now. I thought you are just walking using my aircon here and go out. RSW. RSD. RSD student. Okay, so overview of software testing. Okay, so you have done with the software requirement. You should know that when we have an idea to come up with a software, we plan to do a software, requirement is the first thing. Okay, so that's why you go for your software requirement engineering. For RSD student, I know that you don't have a particular subject called software requirement, but in your software engineering, 2163 in software engineering, you also have discussed the requirement about the user requirement, functional requirement, non-functional requirement. So it's not something new totally. Okay, so what we have as a set of requirement from our SRS, software requirement specification, that is what we are trying to construct here, correct? You guys are on project 1 now, correct? Project 1, started documentation. What you are doing now? Year 1, what you are doing? Have you submitted proposal?
Yes.
Is your proposal has been finalized? Okay, and you have started your chapter 1, 2, 3, 4? No, chapter 1, 2, 3, 4. Sorry, I think I have one student. Where is my student? Where is my one and only project student from batch, year 1 batch? The entire group did not turn up for my lecture. For the program that all. Okay, good. Okay, year 2, what you guys are doing now? Project 1. Started project 1. Have you started to find your supervisor? Preparing proposal? Not yet. Nothing. Okay, next week you are going for briefing. Okay, so sometimes I will be using project as an example because what you do, it will be easy for you to understand. Okay, so normally like your project, okay, you are going for briefing. So after the briefing, they will ask you to prepare a proposal. So you need to convince your supervisor what you want to do. So by reading your proposal, they must be convinced that, okay, this is a good topic. This is a good development. This development going to give something. So let's start it. Okay. So the first thing after the proposal going to be approved, you will start with the requirement. Okay. But of course here for your chapter, you are going to have your proposal. Then you will have your introduction for you to identify your scope, your objective, and so on. Then after that, you will move to your literature review for you to do study of what you want to do. Okay, because when you said you want to develop a software, for example, you want to develop an application, web application or mobile application, you are not the first person coming up with it. So what you need to do? You need to do the literature review to study what is already in the market, so that you are not coming up with something lower than what is already in the market. So let's assume we have a Google Classroom, right? So you are saying that this Google Classroom is not good. Something is still not there. We have this problem, this problem, this problem. So now you want to come up with a better platform. So can you just come up without studying about Google Classroom first? Cannot. So you need to do the literature review for you to understand what is already in the market. So what is in the market, what is not in the market. Then only you can start with your own idea. Then you are going to come up with your requirements. Okay, so a set of requirements, that is what we are going to refer to do the constructions of the software. Okay, so when we do the development according to the requirement or according to the design, can we guarantee the development is going to be 100% correct, 100% working accordingly? Because sometimes there might be misunderstanding, miscommunication, or there is any issues, any technical errors you have made. This might have a defect. Okay, so when we don't do the testing, we might not even realize certain defects exist. So when we do the testing, we want to make sure that we able to identify that and we able to do the correction. Because if you don't do, your user will do. what will happen? Your user will identify the issue. When you as a software tester, okay, I always try to remind with this, you as a software tester, when you identify a bug, it means you are a good tester. It means you have done your job. Good. You do the testing, you identify the bug, you fix it. The more you identify the defects, the bug, it means you are doing your job well. Forget about development team, how irritating they will be, because you are actually identifying whatever wrong thing they have done, because they always feel that I understand the requirement, I understand the design, and I do the code correctly. It's worked correctly when I test it. But when you do the next level of testing, you might identify something else. So forget about that. Okay? But if you didn't identify, let's assume that 100 of bugs, you did not identify. This system has been transferred to the actual working environment. Your user, when they identify one bug, it's going to be a complaint. Can you understand? If you identify the bug, you are doing your job. You are going to get paid for that. If your user, your client identify the bug, it means you didn't do your job. That's why they identify it. So we always don't want that to happen. Of course, we cannot guarantee they cannot identify any defect. They might be somehow, but how critical defect they will identify will indicate how well you have done the testing. It's very important. Okay, so we need to do the checking on the partial software product or on the final software product, so to know how the system or the software behave. Okay, so testing not only being done after we completed the development. Please always take that from your mind. If you always go back to the waterfall model. What happened to the waterfall model? We finish the development, then we push the system, then the testing will start. This is the linear way, am I right? But nowadays, we are not following the waterfall model because it's not going to be work. Okay, because a lot of new requirement will be just coming in. A lot of changes happen. New technologies being implemented. So we actually start the testing as early as possible. Okay, we have to make sure that whatever single things we are developing, we need to test them before we move on. Especially if you are using Agile. Remember? Agile methodology. Is Agile methodology we are developing the whole system in 3 months or in 6 months? How Agile methodology work? Each sprint, how long? Agile methodology is one of the methodology, am I right? Okay, are we completing the whole system in few months time? No. Each of the sprint in Agile methodology, how long maximum we can go? 2 to 3 weeks. 2 to 3 weeks. Not below 2 weeks, is too much. Okay, 2 to 3 weeks. So in that 2 to 3 weeks, are we completing the system? No. It's a big, we cannot. So what will happen? We are working on functionalities basis or module basis. So we are going to develop, we are going to test, and we are going to deploy it out. So it means in every little development, partially working prototype, whatever is it, we must do the testing as early as possible. Even the documentation also, we need to do the testing. Okay, later we will discuss what is this static testing, what is this dynamic testing in later chapters. Okay, so other than that, the testing is also to test the software where it can be by executing or without executing. So this too is the main difference between the static testing and the dynamic testing, because we want to see how the system or how the prototype or how the documentation has been prepared compared to the client's requirement. So this is the overview of testing. So when I said testing, is not only running the code. Correct? So when we prepare a documentation, that documentation also need to be tested. But of course, the way we are testing a documentation and the way we are testing a code cannot be the same. Okay? So this is all what we will discuss in the later chapters. Okay, so the purpose of software testing. Okay, so some of them, they are actually kind of repeating here. Okay, it's just the statement given in a different ways. Okay, so the first one is we want to analyze a program, or we want to analyze the documentation. Okay, especially software engineering students, you must be aware that your program is full with the documentation, because throughout the software development life cycle, in every stages of the software development life cycle, we need to produce documentation. Okay, I'm not sure when you go out to the real working environment there, what kind of methodology your company will use, if they are really into documentation or not, but somehow you need to know. Okay, for example, agile methodology which is working like 2 to 3 weeks, do you expect them to come up with a complete SRS? Cannot, they don't have time. So what they do is they just gather the requirement for that particular sprint, but later they might combine all this, become a complete SRS, but that will be later stage. But some companies, maybe they are still following the traditional way. You must come up with a complete documentation first. We need to refer to this documentation, then only we can start. Maybe the company is full with juniors. You know, when juniors, they don't have certain experience yet. So what they are looking for, a guidance. So when they need a guidance, maybe people are not always there, but documentation will be. So that's why they need to come up with the documentation. So when we said we are doing a testing, we need to make sure that the documentation need to be tested first too. If your requirement document is having a mistake, can it be carried forward to the final product? Are you sure? Are you sure it will not? You are coming up with a software requirement document. Your client say A. You thought it's A+. And you documented the SRS with A+. Got it? And you didn't check, or you did not test the requirement. You did not review the requirement. What will happen? That mistake will be carried forward to the design. Correct? Okay, and you still didn't check the design if it's correct. It means you didn't refer back to the client. Okay, you didn't test them. Now from the design, you start with the development. Am I carrying the same mistake to the coding now? Yes. So now after the system has been completed, the testing has been done, because the testing team didn't know. Correct? The requirement mentioned A+, and when we prepare the test case, we expect to see A+. Correct? And when the coding is having the A+, my actual result will show A+. My testing will be pass or fail. When I expect to see A+, my actual result is showing A+. Is my testing pass or fail? It's a pass. What I expect to see, I'm seeing it. Later, you call your user to do user acceptance testing. You know what is user acceptance testing? Your user need to do the test for them to accept the system or to reject. Because you think everything is okay. So now after 6 months, let's assume, after 6 months, your user is coming in. Throughout the 6 months, you did not communicate with your client. So now when the user is doing the testing, is it correct what they want to see? They expect to see A, but the system is showing A+. What they're going to say? This is not what I said. This is not what I want. So, imagine how much of resources, how much of time, how much of money we are going to be spending to do that fixing. Because it's a completed product now. Do you think it's going to be easily? Of course, it sounds like A to A plus or A plus to A is something easy. But, a lot of things to change. You are going to be wasting a lot of things. So let's assume if we have done a checking on the SRS with our client. We have done the review if this is what the client said. Am I going to waste that much of money, time and resources fixing something on a document? Not at all. It's not even going to be 5%. Got it? So that's why testing is not only about running the software to see, but we need to start to analyze from the documentation. So whatever we can fix it there, it's going to be saving us later. Got it? Okay, so the second one is to check if the system meets the requirement and to be executed successfully in the intended environment. So whatever is it, no matter how good you do the system, how well the system is functioning, how nice is the user interface, is it meet your client requirement or not? If it's not meeting your client requirement, sorry, they're going to reject it. You are going to do something, repeating some changes again and again. Okay, and also if the developed software is working on their environment or not, it's very important. Remember group 1 yesterday we were talking about development environment, testing environment and the working environment. So no matter how well it's working on the development environment, on the testing environment, they don't care. Okay, what they care is it working on my environment? So it is very important for us to do the testing to confirm that the software able to work on the client actual working environment. Okay, then to check if the system is fit for the purpose. So this is something like the requirement, what they expect. It must fit to do the functionalities. It must able to do the operations. To check if the system does what is expected to do. So the same thing, it must do what is expected by the client. And to identify and correct the defect. So this is our main, our side as a software tester. Our aim is about I need to identify and correct the defect. Okay, if I don't do, what will happen? User will do. Okay, then to check whether the user needs satisfied. So this is something same like the requirement. Then to avoid user detecting. So this is what we don't want. Because if you don't detect, user will detect. Okay, no matter how small the defect can be, it's going to be a big complaint. So we don't want the user to detect what we did not detect. So it's better for us to do the testing, for us to identify the defect so that we can fix it by the time we will deliver out the software. Same thing for your project. So let's assume in your project 2 later, when you do the development, after the development, what will happen? You need to do testing with your supervisor, with your moderator. Correct? So let's assume by the time you want to do testing with these 2 people, okay, you didn't test your own. So what will happen? Whatever you did not expect to see, your supervisor and moderator see it. Okay, so let's assume if that is how they are going to give you marks. So what will happen is going to affect your marks. So the same thing goes here. If you did not do the testing, you did not identify and fix the defect, your user will do that. Okay, then the last one, to provide a quality product. So when we say how good, how well, it's include with the quality of the product. So at the end, when your client able to see a good system which have a good quality and functioning according to their requirement, they are going to accept the system. Okay, because we always want to avoid rejection of the client. Let's assume you are wasting 6 months and then your supervisor say no. The moderator say no. This is not what we expect. What will happen now? Are you going to repeat your project too now? Can you imagine? So we don't want that to happen. So the same thing goes like the client. Your supervisor might be your client. So you need to always communicate with your supervisor to get their feedback, to show them what is happening. This is what we plan to do. This is what we have done. This is what we cannot do. It's very important. Do you understand? So that at the end, towards the final preview or final testing, your system is not going to be rejected. Got it? Okay. Okay, so who perform testing? We have different types of testing, am I right? We have white box testing, we have black box testing, we have static testing, we have dynamic testing, a lot of varieties terms being used. Okay, so in a general, okay, when we say testing, okay, who are the people going to perform the testing, we can group them into these three different groups. Okay, the first one, of course, the common one will be the software tester, because by their name they are carrying it, right? They are going to be the one testing the software. Okay, are they the one going to develop the software? Are they the one going to do the fixing of the software? No. Okay, they are only there to do the testing. It means to identify the defect and to report back. Where they are going to report back? Where the testing team going to report back the defect? Developer. Okay, so as part of the testing, this software development team or developers or programmers, when they do the development, they also do the testing. Correct? But the way they are doing the testing will be different compared to the testing team. So this is where we talk about white box testing, black box testing. Can I know what is the difference between these two? White box testing and black box testing, what is the difference?
Knowing the function, knowing what it does, and one is not knowing what it does.
Sorry, come again.
One is testing, knowing what it does.
Sorry, I cannot hear you. Okay. Do you have anything else to say? Okay, so when we say white box testing, I think most of you already know about it. Just to recall back. So when we said white box testing, it means we are viewing the system or whatever we are developing as a white box. White box here means I can see what is happening inside or at the back. You know, normally we have this term, right? Front end and back end. What is front end? What we are seeing through the UI. user interface. When we say back end, it means the logic part, how the code has been written, how the code is working, how the code is doing the calculation, the scripting, all this. Got it? So when we said white box testing, it means we are viewing the system as a white box where we are trying to understand the source code at the back. Got it? So when we are analyzing the source code, we are trying to see the control flow or the logic flow of the code. We are doing the testing according to that. It means if the code is working correctly to do this function or not. So we will need the programming knowledge here. So can I force software testers to do that? No, because software testers requirement, their job requirement, of course it's good for you to know the programming, but we are not forcing them to do anything about the development of the coding unless you are the only person doing all the job throughout the SDLC. You know, there is some companies like that. They don't want to hire too many people. Okay, you are my victim. You are going to do all the job here. You are the one going to talk. You are the one going to write the requirement, do the design, do the coding, do the testing, everything. So that is different story. Okay, so when we said white box testing, that will be during the development stage. It means will be done by the software developers. So once we have completed the development and the developers has tested the entire development and they say, okay, now the system is ready to move for the testing team to do the testing. Okay, so now when the software testing team want to test the system, they are going to see the system as a black box where they don't try to see what is happening at the back end. All they care about is my UI. Is the front end giving me what I expect to see based on my test case or not? So they don't care how is the code is working at the back. Got it? So they don't try to analyze, they don't try to understand the back end source code. They don't care how the logic all work. I expect to see A and am I seeing A? If I see A on my UI, the test case is passed. If I expect to see A but I'm seeing B, it means my test case is failed. Why it's failed, how it's failed, I'm not going to bother about it. I will report it back to the development team. So this is why development team and the testing team cannot have a good relationship. Got it? I have spent all day and night doing the coding, and these people can easily find, you know, those kind of things. But this is actually make the project a big, huge, a huge of gap. So these two teams actually they need to work together. They need to have a proper communication. Then it can improve the software testing also. Okay? Then other than these two group of people, end user will be part of the testing. So of course end user, they are not going to do white box testing because they also don't care how the code and everything. Okay? And they don't really care how testing team do the testing. All they want to see is, am I able to accept the system or not? So that's why user acceptance testing, we are using the user. Because no matter how good we are saying it, the final word is coming from the user. Is the user able to use the system, and if the system is fulfill everything what they said, and then they are going to accept it. So if you see, when we say white box testing, the scope is very limited. Because what we can test here, only the functions. Am I right? If the functionality is working, okay, if the function to print something is working, display out something is working, if this module is working, if this integrated modules or system, they are working on it. So our focus will be more onto the functions. But when we say black box testing, the scope will be much more huge. I can cover the functionality side and also the non-functionality side. It means I can broad up the scope to see how is the performance, how is the recoverability of the system, how is the stress level of the system, how much load the system can accept. So all these can be covered under the black box testing. So as part of the black box testing, we also have the user acceptance testing. Clear? Got it? So can understand why testing is not only about the software tester, but also involve the development team and also the end user. Okay? Okay, so there is some terms here which we want to recall back. Okay, when we said about testing, so there is some terms we want to see. So we have software errors. Okay, software error is a mistake by a person or error made by a person. So normally, like the programmer who do the coding, they might do any bad programming or any incorrect in the programming. So this is an error, okay, which is caused by us. Okay, so other than programmer, maybe the people who is doing the documentation, like writing the requirement or doing the design. So when they do any mistakes on the documentation, it is part of the error, part of the software error. So whatever mistake the human did, okay, it's turned into a software fault or software defect. Okay, I cannot say that when you do mistake, that is a defect. No, that is an error, human error. Okay, and this human error will turn into a software fault or software defect. So that's why whenever I'm saying of something inside the software, I'm calling them as a defect. So now, due to the human error, the human mistake, now there is defect inside the documentation or inside the program or inside the system. Okay, so other than defect, it also can be called as a software fault or software bug. Okay, so now due to the human mistake or human error, now there is something hidden inside now. Okay, so this software fault or software defect, I'll be back this up, will turn into a software failure. Okay, due to the human mistake, there is a software defect or software fault happen inside the software, and this defect can turn into a software failure. So software failure means it might not able to perform what it supposed should perform, or it might not able to fulfill the requirement given by the client. Okay, the reason why we say failure here, because user is not going to accept that. Okay, so due to the human error, the human mistake, okay, during the development, during the documentation, during the designing or whatever is it, okay, it will turn into a fault or defect. Okay, and this defect will turn into a failure where user doesn't want to accept the software because it is not doing what I expect. It is not fulfilling my requirement. So, is it all the error going to be a defect? Is it all the defect will turn as a failure? You know, sometimes when programmers do mistakes, right? Okay, some can turn up as a defect. Some might not turn up as a defect immediately. and some will never turn up as a defect at all. So the same thing goes, some defect or some fault will turn into a failure and some will not. But can we know which one? If we don't do testing, can we able to identify this one? Which one will turn into and which one will not turn into? Can we guess that? Cannot. Okay, so we can never guarantee what type of software error happen. We cannot guarantee what type of software defect it's turned into, and we cannot guarantee which one will turn into a failure. But the possibilities is there or not? Yes. So that's why we need to conduct the software testing. So if you see, this is a simple figure to show the connection between the software error, software fault and software failure. So the one in a diamond shape is the software error, the circle is a software fault, and the star is a software failure. Is the amount of these three symbols are same? Are they same? No. So if you see, the numbers of software error is huge. Am I right? It's more. Then some of the software error turn into the circle, which is the software fault. Some. And some what happened? Did not. So the same thing goes, some software fault turn into a software failure. And some remain do nothing yet. Or it might not do anything yet. Correct? So if you see as a conclusion, not all software errors, it means the human mistakes, will turn into a software fault. It means it's going to be a fault inside the program or inside the software. And not all software fault, okay, will turn into a software failure. So it means not all the defects can disturb the functionalities, can disturb the performance, or can make the software not perform as how it is. But we cannot guarantee which one will do that, which one will not do that. So to be on the safe side, we must conduct the software testing so that we can identify the software fault or software defect before it will turn as a software failure. Got it? Can I control software errors to happen? Can I sit next to a programmer to say, don't do this, don't do that, check this, check that? We don't have better things to do. So we cannot control human mistake. We cannot control human errors from happening. It might happen, it might not happen, it can happen a lot, it can happen less, okay? It might. So the only thing what we can do is how we are identifying the defect which is caused by them, so that it will not turn as a failure. Got it? Okay. So another one more term in the between of this is defect masking. Okay. What is mask? What is mask? Covering something. Am I right? We are still having mask. Huh? Okay. So defect masking here, it means it is actually hiding the fault, hiding the defect. Okay. So what happened is there is some defect is actually hidden by any other defects. Okay. Maybe in a module, in a functionalities, there is a defect happen. Okay. But this defect is actually not turned into any issues yet, not turned as a failure yet. Okay. So this defect has been hiding on other defects. Okay. So when we do testing, okay, or when we identify a defect, then another defect is coming up. So it's something like a failure happened after the hidden mask or after the defect which is hiding another defect has been corrected, then the one inside is coming up. Okay, so sometimes when we do the testing, we might not cover a proper percentage of testing. Maybe when you identify one defect, then you say, oh, okay, we are done. Okay, but there might be any hidden defect happen. So let's assume when you identify a certain percentage of defect on a module, there is high possibilities more to come. So when we are conducting the testing, the way we are covering the scope, it is very important because this defect masking can happen. So we must do the testing to test more so that we can able to bring up whatever hidden at the back. Okay, so that is one term. Okay, so this one, just to recall back, validation, verification, because these two V, they are very important in software testing. Okay, what is validation, what is verification? We always have this statement, right? Are we building the right system? Are we building the system right? Okay, when I was doing my degree, I always cried because I cannot differentiate them well. Especially when you see on the test paper, you will really confuse. So how you guys differentiate them? What is verification? What is validation? Without seeing this, how you yourself, okay, when I see verification, this is the term. When I see validation, this is it. How you differentiate that? Any tips to differentiate verification and validation? Because that statement itself is confusing, right? Are we building the right system and are we building the system right? What is the difference between right system and system right? So I was not the only person confused, is it? Okay, good. So let's confuse together. No, I already fixed myself. I already able to see them clearly now. Okay, so if you see, right system means we are referring to the product. We are referring to the system, what we have developed. Okay, and when we say it, are we building the system right? It means the process which we do to build the system, is it right or not? So when we say validation, we do the validation on the end product, on the software which we develop. And when we do verification, it means we want to verify if the process which we do throughout the software development life cycle before we get the end product is correct or not. Okay, so the important term here is verification means process. Validation means product. Okay, you know what is process, right? For example, software requirement process. Software requirement engineering process, software design process, software testing process. It's a process, right? Okay, until we get the final product. So here, when we say validation, we are evaluating the software at the end of the development. When we want to have the product, it means we do that at the end of the development. And when we set verification, throughout the software development life cycle, we do different process. We move from one stage to another stage. Am I right? So we need to verify if every stages, the process which we do the milestone which we get from the process is correct or not. If your SRS is not correct, can your design correct? If your design is not correct, can your prototype correct? Cannot. So we must do the verification to determine whether this SRS which we produce at this requirement stage is correct or not before we move to the design stage. And if this design document which we do during the design stage is correct or not before we move to the prototype development. So we must do the verification throughout each of this process. If our process is correct, will our product be correct? Yes. So that's why we do the verification on the process during the stages in the software development life cycle. So it means when we say design, it means the previous phase is the requirement. When we say development, then design is the previous phase. Got it? Before we are moving. But when we say validation, it means no matter how much I do the verification, I still need to validate the end product to confirm that. So now after I have the end product, I do the validation. I do the evaluation to confirm that the software is correct according to the requirement. Got it? So the important keyword here is validation is on the product. Verification is on the process. Validation is at the end of the software development. Verification is throughout the software development life cycle. Got it? Hope I helped the confusion or I make it worse. Okay. Then the software testing term. Okay. So different sources or different standards, they have give us different definition of testing. Okay. So the definition is actually doesn't matter because how we do the testing, when we do the testing, on what we do the testing is what matters. Okay, so from IEEE 8 to 9, so they have mentioned that software testing is a process of exercising or evaluating a system or the system component. So it means we want to evaluate that. So this can be done by manual way or automated way. You know, manual way means we as the human being, we conduct the testing manually by ourselves. And if we say automated means, what we use? Automated testing means what we use. We don't do the testing. Let it be automatically work. We will use the automated testing tool. Okay, so long back there is no testing tool, or even if there is testing tool, is going to be involved with the licensing, expensive, all this. So they go with the manual testing. But nowadays we have a lot of open source automated testing tool because people are tired. We cannot be doing the repetition of the testing again and again for reason. So we need help of the automation testing tool. So let's assume years back when we are saying about waterfall model, do people really know about requirement? Or they just depend 100% what we are giving them? Let's assume like 30-40 years back. There is no much software that time. There is no much of system that time. Nothing even. So when the software company is proposing something, the client will be very happy because they don't know what they want that time, correct? So whatever the company is giving, they are accepting them. So in that case, will there be much changes happen? Can they demand for requirements? Cannot, because they don't know what they want. So in that situation, we can do a fast software testing, correct? We can just do one time of testing, everything is done, okay, now it's your system. But can we follow that nowadays? Can you just give whatever you want to your client, and do you expect your client say, okay, thank you? Do you think they are not going to come up with a requirement like every 1 hour? Oh, because suddenly there is this new technology. Oh, can we do this? Can we change this? Can we add this? Can you imagine how many things they will bring up in one day? And especially if you are doing, if you are using agile methodology, clients sit next to you. You know what does that mean? They will be commenting for every single thing you are doing. So in that case, what will happen to our testing? Can we stop the testing? Can we say that I have done the testing, we have finalized it? Never. Because every time when there is changes happen, there will be changes on the code. And you must redo the testing again and again. So when the tester will be resting. So that's why we need the help of the automation testing tool. Okay. Then from the Myers, which is the author for the software engineering book, so they indicate software testing as a process of executing a program with the intent of finding errors. So our purpose of doing the testing is we want to find the errors made. Okay. Then from IEEE is a process or sequence of steps performed for a given purpose. Okay. Okay. So far, any question? Before I will move with the 7 principles of software testing. Any question? Is everyone okay? Still okay?
No.
Is everyone okay? All good? It's just recalling back whatever you might forgot. Okay, because you already get to know all this before. So I just try to polish it back. I try to add up little things. Okay, so let's move fast with this 7 principles of software testing. For my lecture, I don't always give a break. If you need a break, you need to let me know, because I prefer to finish early. Okay, I prefer to continuously do and finish the class early. Because I don't want, because you need to be moving also, I need to be moving also to the west side. So I don't drag my lecture much. Okay, so is it everyone okay for us to continue? Okay, let's finish it. Okay, so you take your break later. Okay, so the first principle, testing shows the presence of defects, not their absence. What you understand from this principle? Testing shows the presence of defects, not their absence. So what we are trying to prove here, why we are conducting the testing? What we are trying to do here, can we guarantee our software has no defect? Cannot. We cannot guarantee. Am I right? So the purpose for us to conduct the testing is we want to identify the defects. We want to prove the presence of defect. We are not trying to hide the defect. So I'm doing the testing not to prove that my software is good without defect. But the purpose why I'm doing testing is I want to identify the defect. So I'm trying to show the presence of the defect. Okay? Got it? So we want to identify the defects, how much defects we can identify so that we can report back to the development team for them to do the fixing. So our testing here not trying to prove that the software is good. There is no defect at all. It means you didn't prepare the test case properly. It means you didn't do the testing properly. That's why you didn't identify the defect unless the software has been tested again and again for many times. Got it? So here we are not trying to prove for the absence of the defect, but we want to prove the presence of defect so that we able to identify the defect. Okay? So the second principle, exhaustive testing is impossible. Can we test everything? Can we test every single thing? Can we test every combination of data? Is it possible to do that? Okay, let's assume I have a text field here. You know what is text field? Anyone don't know how text field look like? Okay, so this text field can only accept an integer from 1 to 1000. Understand the requirement? It can accept integer 1 to 1000. Okay. So, am I going to test 1000 times to prove that it can accept 1 to 1000? Do I have time to do 1000 times of repetition of the same testing on one single text field? Are we okay to do that? That is the valid one, correct? And I still need to prove that anything less than 1, anything more than 1000 must not be accepted. Correct? It means it's considered as an invalid. So if I want to prove the invalid integer here, where am I going to stop? Do I have an ending here? To show the negative side, to show the exit of the 1000? Do I have an ending here? No. So when we say exhaustive testing, it means we are trying to test every combination of data, of input, which we cannot control. So we must choose the right techniques how we want to conduct the testing, because it is impossible to test everything. So exhaustive here, you should know what is exhaustive, right? So same thing applied to the testing. So now for the same text field just now, you know, the same text field just now, how many testing suppose I should do? How many testing suppose I should do? Let's assume I ask you to prepare test case to test this text field where it can accept 1 to 1000 only. So how many test case I need to have? Minimum. One. Only one. 4. Sorry, 4. Okay. Positive test case. It means to prove the 1 to 1000 as a valid input. Then my negative is, okay, negative test case means when we are giving the invalid input. So invalid input, I have 2 different groups, am I right? One is below 1, one is more than 1000. So the minimum test case I need is 3. Because doesn't matter what integer I'm giving from 1 to 1000, suppose should give me the same reaction. Whatever I give below the 1 should give me the same reaction. And whatever I give more than 1000 should give me the same reaction. So I just need minimum of 3 different set of data to test this 3 range. I'm done. Correct? So we need to know the right way, the right technique, how we are going to conduct the testing. So that's why we will learn this software testing technique also. Okay? So the third one, testing activities should start as early as possible. So as what I've mentioned, we are not going to wait for the software to be developed, then only we want to check on the requirement. It is too late. Okay, so when we said should start as early as possible, it means throughout the software development life cycle, in the early stage of the life cycle, we can already start the testing. If you are coming up with a proposal, don't you review the proposal? Do you think your supervisor will just accept your proposal? Okay, we are okay with that. They are going to review it. They are going to do the moderation, am I right? So that is actually part of the early stage of the testing. Okay, so testing should start as early as possible. Okay, then the fourth principle is defect clustering. So defect clustering, what is cluster? The most famous term for the past 3 years, am I right? Start 2020. We always heard this cluster, that cluster due to COVID. What is this cluster? How this cluster happened? Not this cluster, COVID cluster. How it's happened? When one infected person get in touch with others, the normal one, they will be get infected too. Then it become a cluster. So the same thing goes here when we said defect cluster. In a software, defect is not nicely arranged. You know, like, okay, this function has 2 defects, this one has 3 defects. No. Okay, so normally this defect can be one or it can be a cluster of defect. So like what I said just now, when you identify 1 or 2 defects in a module, there is possibilities a cluster of defect to be there. Okay, because these functionalities which has been affected might cause defect for another function, or it might cause defect for another modules. So this can actually be a defect. So when we are doing the testing, we must make sure that we able to cover all this range of defects. Okay. Then the fifth one is pesticides paradox. So the pesticide paradox. Okay. You know how efficient mosquitoes can work. Am I right? You know mosquitoes, right? Okay. So the more you are spraying them, you know, spray. The more you are spraying them, is it really going to kill them? Because it's not really working anymore. It is not really effective for them anymore because they get immune. Same thing to our body, am I right? Every time when you have headache, you are taking Panadol. There will be a stage where the Panadol is not working anymore. You feel like after take Panadol also the headache is not going because your body gets immune. So the same thing goes here. When we are doing a testing, okay, just because you don't identify any defect, you cannot be repeating the same steps or test actions again and again with the same data again and again to expect miracle to happen. It will be just wasted of resources, just wasted of time. So if you don't identify any defect from this test action, this test data, you don't see something but you know that something is not okay, what do you need to do? You need to modify the test case. Then only you can see there will be a changes happen. So just because we are repeating again and again doesn't mean it's going to be effective testing. Okay, so that is what it means by the pesticide paradox. So they are not going to be helpful to discover any new defect. Okay. Then the sixth one is testing is context dependent. Okay, so you know we have varieties of softwares working on different platforms, working with different programming language, working with different technologies, different devices, different operating system. Can we test them all in the same way? Let's assume we have Maybank to you. We have two different versions of Maybank to you, am I right? We have web application, we have mobile application. Mobile application means not opening on the web browser on the phone. It means the app which we install. Can I test this web application and the mobile application in the same way? Cannot. Because it is not fulfilling their requirement. Okay, the performance will not be the same. The operating system will not be the same. So when we want to conduct testing, we must conduct according to the system context. Can I test online banking and e-commerce system in the same way? Like Maybank to you and Lazada. Can I test these two systems in the same way? Cannot, because they are functioning in totally different way. Okay, and the last one is no failure means the system is useful is a falsity. Okay, so just because you have tested the system, you did not see any defects, doesn't mean the system is useful. Okay, because your client need to confirm that okay, there is no defect, there is no failure, and the system is fulfill my expectation, my needs. Then only we can say the system is useful. So it is very important for us to not conclude by ourselves. Just because there is no failure happen doesn't mean the system is useful. Correct? Okay, so that's it. So I will stop until here first. So I will continue the balance part of chapter 1 next week. Okay? Don't forget to mark your attendance.